our next lesson is going to be strictly based on financial applications, and we're going to be using the Solver application on our TI graphing calculator. So if you don't have a TI graphing calculator, this lesson probably won't be really educational for you. You're just going to kind of watch and learn. But for the rest of us, we have our TI 84. Most of us are using the 84. Color edition doesn't really matter. As long as it has the financial applications tool, you are good. So if you're using one from the calculator case at school, I put it in test to press mode, which means that you're not going to see all of the things that you see on my emulator calculator because I shut down a lot of tools that are available to you for the classroom calculators. The one that you're going to want to use is the one that's still there. So don't panic. We can do all of these things in calculator, in a calculator from our case. So these first few questions are just review. When we do this lesson during class, we're going to review all that. So here, this little formula is on your notes page, and we're going to take out what's called an annuity, a vocab word for you. We're going to make deposits like every month or every few months, whatever we set up. So it's going to automatically withdraw from our checking account or something like that. I do this for my children's college savings. And every month we donate so much money to that account. And it collects interest over time, and because I'm also depositing to it, it's not as simple as just the basic formula that we've been using in section 3.1 and 3.2. So we can determine the future value of the annuity. We can determine a lot of things, actually. And if I have a goal, like I want a certain future value, we're going to be able to kind of go backwards and decide how much of a payment should I be making every month to make sure I hit that mark. If my kids need $150,000 for their college by the time they're 18, I might need to adjust the amount that I deposit every month. I don't know if I want to do that problem. That sounds like a scary problem. So the vocabulary here is the same vocabulary that we're going to be using on our calculator. So the payment is the deposit amount, but it's the payment that you're making every single month. So if I'm depositing $100 a month, that's 100. Future value is what you want your balance to be after a certain amount of time. CP per Y is compoundings per year. Interest rate, they're using I here in your calculator instead of R, but it means the same thing. And this formula is actually programmed within your calculator's memory. So the good news is you don't actually have to do any of this math as long as you know where to put the correct variables within the program solver. So time value of money solver. It's abbreviated TMV on your calculator. So this is on your notes, but when we go to look at the calculator, it might look a little different than this if you're using a TI-84CE because it's the color screen and it's cool and it looks pretty. But N is the number of payment periods. So N for monthly would be 12 for every year though. So we have to be careful because it's over the course of the entire annuity. So it might be like our normal N from our previous questions where 12 was monthly, but if it's over the course of 18 years, I have to do 12 times 18. So we'll see that in a second. Present value is just what it currently holds. Future value is what I want it to hold at the end. Payments per year and compoundings per year are typically for us going to be left at monthly. Nothing's working for me today, guys. It must be a Monday. Oh, for Pete's sake. So you might want to make a little note. Typically, it's going to be 12 here and 12 here. So if you're not sure if you're supposed to change it, when in doubt, just use 12. Let's see. Oh, I was interest rate. So you need to know these is just a little note that, if you're in the middle of a test and you're like, I don't know what to put in for future value. Well, I'm actually asking you that. That's the whole point of the question. So you have to figure that out yourself. So this question, an investor pays $600 quarterly into an annuity. The annuity earns 7.24% interest. What will be the value of the annuity after 15 years? So the easy one to pull out there is the interest rate, and they want it written as a percentage, so you're going to write literally 7.24. You don't even have to change it to a decimal. The N is the number of compoundings that you're going to have over the course of the entire annuity. So quarterly means 4 times a year, but you have to multiply that by 15. So you can either, change that to a 60 because you know what 4 times 15 is, or your calculator will actually accept the multiplication problem of 4 times 15. So that's excellent. Present value. For this question is zero, yeah. Because you don't have anything in the account right now, but you're going to be making payments of $600. The future value is the thing that we're going to solve. So what I'm going to do in our notes is I'm just going to put a big empty box here because I'll show you what we do on the calculator next. Payments per year, excuse me on that one. It's not 12 this time. I kind of lied to you on the last one. Because I'm compounding quarterly, we're going to be doing 4 payments per year, 4 compoundings per year. And then we are going to go to our calculator now so I can show you how this looks. So remember, if you're using a classroom calculator, it's going to look a little different than mine. It's not going to look like that because we're not doing any of that. All right, get out of the graphing thing if you're there, if you followed me. All right, so in the applications, if you are using a classroom calculator, the only thing you'll see is the finance option. So we're going to open finance, and then the very first one is TVM Solver, time value money solver. So choose that, and then remember N was 4 times 15. The interest was 7.24. Present value, I don't, and we'll find out in the future of doing these questions where 0 is just in place of things that either I don't know or like aren't going to change the problem in any way. The future value is something I'm going to calculate in a second, but I do need to change the payments per year and the compoundings per year to 4. Now, for payment, we're going to always leave them as end. So go ahead and just leave that at the end. And then the thing I want to know, remember, was the future value. So get your cursor in the future value position, and then we want it to actually solve something. So right here in green above the enter key, it says solve. So you're going to use alpha to shift to the green keypad, and then choose solve. Oh, I did something wrong. Time out. What did I do wrong? One moment. I'm back and I feel dumb. So I never put the payment in. I'm paying nothing every month. This is really stupid of me. So weren't we putting $600 in? Oh my gosh, it's Monday. Forgive me. All right, now I'll go to the future value, and now we're going to solve it. So alpha, enter, and then boom, there you go. Now it shows negative. This is kind of confusing. Someone's paying the money, and it's calculating it as a negative because the bank is paying the money to your account. So don't worry about the negative value. That's just the money that's going from one account to another account. So over the course of those 15 years, our annuity is going to be worth $64,102.91. So we jot that number down. Excellent. Sorry about that. Bruce, I was having a moment. This next section, this next slide is not in your notes, I believe. So they just kind of went through those same. That would have been helpful there. It would have shown you exactly what to type in. My bad. All right, move it along. So there's that formula again. I'm not going to make you solve this formula by hand necessarily. We're going to be using the application. So this next example is in our notes. So this one, I'm going to borrow $170,000. So, which means I'm going to need to pay it back, clearly. So this number right here is going to be our present value of the loan. And 30-year loan, so there's your time, and it is collecting monthly payments. So for our N, monthly payments over a course of 30 years is what we're going to put in for N. Present value is $170,000. The future value is, I'd like it to have no balance anymore. And then compoundings per year, 12. Payments per year, 12. Because it's collecting interest 12 times a year, but it's also I'm paying out 12 times a year. The interest rate is 4.5%. I see that right there. And then we leave it as 4.5. The payment is the thing that we are going to be solving. So get this entered into our calculator. Let's see if I can do it without messing up this time. All right. So all the way at the top. It was 12 times 30, which I know I should be able to do in my head, but guess what? I can't. 360. All right. 4.5 is the interest rate. Present value is $170,000. You know, you guys are very lucky. I kind of wish someone would have taught me this before I bought my house, because I probably would have bought a house more in my price range, I suppose. All right. Payment, remember, is the thing we're going to find, so I'm going to leave it alone for a moment. Future value, I'd like it to get down to 0, so I don't owe anything. And then 12 payments per year. 12 compoundings per year. It changes it automatically, so that's nice. So go back up to payment. this is the thing I'm going to need to calculate. So alpha solve. There we go. So looks like my monthly payments are going to be $861.37. Now there's a follow-up question to that. And this is kind of the one that really messes with your mind once you become a homeowner. Just because you took out a loan for $170,000 doesn't mean that's what you actually end up paying off. So we're going to pay $861.37 every month. But a good chunk of that is going to go towards interest. Now you'll find also when you're a homeowner that the amortization of it is a little different. They front load the interest payments, so that way if you end up defaulting on your loan, you end up paying a lot of money to the bank rather than paying off on the house. So warning on that one. So if I paid this amount exactly for 30 years, if I did $861.37 and multiplied it by those 30 years, but remember it's 12 payments per year, oh boy, I'd end up paying $310,093.20. It's a lot of money. So your $170,000 house just priced pretty much. Yeah, it's a lot. All right, I don't want to think about that one anymore, guys. All right. So that was the steps that we already went through. So I'm going to move on to the next screen here. It says, here's your assignment. Boom. I think what I'm going to do next is I'm going to open up to 4B. So if you have your notes page, go ahead and grab 4B, which is that guy. And this worksheet's kind of interesting because some of the problems can be solved like the old method that we used to use for Algebra 2 finance problems, like if we're just compounding simple interest or compounding interest where we don't add to the annuity at all. You can use your old formula from Algebra 2. And some of these can be used with the solver, some can be used both ways, but the ones that have little stars next to them cannot be used with the TVM Solver, so don't even bother because you're going to get really confused. Just like this first one here. Simple interest of $4,000, 6.2% for 8 years. Simple interest formula is principal times rate times time. So if we take our $4,000, and this time we do need to write it as a decimal, 0.062 times 8. I already calculated this, so I'm just going to steal my answer. It's going to give you $1984, but that's just the interest. And they wanted to know find the simple interest, but if they wanted the actual value of the account, what you'd have to do now is take the $4,000 and then add that $1984 to it. So 5984 is actually the value of the, I don't know if it's a loan or an account or whatever, but the present value is that. All right, number 2 doesn't have a star next to it, so if you would like, you can go ahead and use that TVM Solver. But I think when I did this question, because it felt very Algebra 2-y to me, I went ahead and just solved it the good old-fashioned compounding interest formula way. So 1 plus 0.062 compounded monthly, and then this is 12 times 8 right here. So if you wanted to use your solver, you're more than welcome to. There's going to be no payments. So if you're using your solver, when it says payment, put a 0 there because you're not adding to this investment at all. You're just collecting interest. So when you type this in your calculator or you do the solver, you get $6,560.18. So it doesn't hurt to go back to your roots, guys. All right. So I'll let you look at number 3. It says continuously, so you're going to be using PERT. I'm assuming this has probably been set up as a homework assignment for you. So number 4, let's go ahead and use the solver this time. So if I have $10,000, I'm going to earn 5.5% compounded monthly. How much would you need to invest today to reach your goal? So again, you can just set up the equation like you did in Algebra 2, but in order to find this answer, you'd have to do a little bit of equation solving with logarithms, or you'd have to use your calculator's intersection feature. So let's go ahead and use the solver. So the number of payments, 5 years from now, they said at some point here. So if we're investing 12 times a year for 5 years, that's what I'm going to put in for N. And then the interest rate is 5.5. The present value is nothing. Well, you know what? Let's back up. Let's set up the present value as my calculation. The payment per month is nothing. That's what's going to be a 0. The future value, I want it to be $10,000, and then 12 compoundings and payments per year. So putting those numbers into my calculator, if you're going to do that, please pause this video and enter them. But I already solved this, and I got 76. So okay, so it looks like we need to invest $7,600.50 specifically. Oh boy! All right. Good luck getting that together. All right. Not all the problems are exciting at the end, guys. Sometimes it's bad news when you do the calculations and you find out. People who are trying to retire get this news all the time, so they'll go sit down with a financial planner, you know, at my age, and then we find out, like, oh man, we are not on track to ever retire. So we have to start investing more money. We have to make cutbacks in our day-to-day spending. It's just bad news all around. All right, number 5 cannot be done with the solver, so make sure you're setting up, it says compounded quarterly, so you're using your formula. But they want you to compare the two. So 5.2 compounded quarterly versus 5.12 compounded daily. So quarterly would be n equals 4, daily would be n equals, we'll just say 365. And they want you to compare, and they don't tell you how much to invest. So just make up a dollar amount because it's going to be comparatively the same. You can invest $1 for all I care. And you really don't need any. I mean, you can just use the formula with a 1 in place of the initial principal. So all you really need to do is set up, you know, this part of the formula and see which one gives you a bigger decimal. So I'll set up 1 with you, and then I'll let you do the other. So 1 plus 0.052 quarterly. And then they want to know, they don't really tell you a time value, but it doesn't matter. So we'll just say to the 4th power here. So here you're going to set up 365 for your ends, and you're going to compare these two decimals. All right, let's do number 6 together, and then I'll leave you number 7. So for number 6, we have a 40-year annuity compounded monthly. So 40 times 12 is going to go here. The interest is 6.5. I'm going to invest $50 every month, so that's my payment. If you invest $50 every month, blah, blah, blah. Okay, so the present value is going to start at nothing, and then the future value is what we want to calculate. So pause the video and get all these things entered into your calculator, which I already did, and my answer is 114,180.95. So this is a handy little tool. I'm going to let you do number 7, which they just change a few things. You're going to invest $100 at 7% for 45 years. And you're going to see your money grow, and I think you'll be surprised how much more money you have. All right, this one. You want to have $1 million before you retire. Me too. All right, you are willing to work and make investments for 50 years. All right. 8% interest, and we're doing monthly contributions. So for N, it's 50 years times 12. The interest rate is 8. Present value, I don't have any money yet. I'm going to make some amount every month. I don't know. My future value needs to be $1 million. You don't have to put commas. And then 12 compoundings and payments. Pause the video, enter all this into the TVM Solver, which I already did, and then turns out, you know what, it's not as bad of news as I thought it would be. We only have to make $126.08 every month to invest into this account. Over 50 years, so bad news for Abruzzo because it may not live that long, but that's okay. All right, number 9. You want to borrow $7,000 to purchase a car, paying off a loan over a 5-year period, and we're making monthly payments. And how big should those monthly payments be? At 6.8% interest. So 5 years making monthly payments. Interest rate is 6.8. Now the present value of your loan is $7,000. The future value better come out to nothing, so I don't owe any more money. We're going to be calculating the payment, and then monthly payments and monthly compoundings. So again, pause the video, get these items set up into your equation solver, And by the way, if you don't have that TMV solver and you have to solve it by hand, you have to go back to that really nasty formula, which, you know, it's okay. We could, but why? All right, so I already did this question. Turns out my car payments are $137.95. It's not too bad. I could probably get a nicer car. Or not. All right, so looks like that's the last question. I'm going to let you finish that one. Hope you enjoyed perusing the TMV solver. I did. I love that thing. That's great. Enjoy.